Hey, yo, 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 yo. Hey guys, let's get into systems of linear inequalities. So, a system of linear inequalities is when we have a system made up of two or more inequalities now. So, very similar to a system of equations, but now we're looking at inequalities. The solution to that system is the ordered pairs that make both inequalities true. So, if you have not watched the video for 4.4, you have to watch that first. Very, very, very important. Now let's get after it. So the way we solve a system of linear inequalities is we graph the system, both equations of the system, on the same graph. This is the only way to show the whole solution. So I'm going to graph them both, and then we'll show what we do. So y is greater than x minus 2. I'm going to start from my y-intercept at -2, up 1 over 1 for x. And I know it's a dashed line because there's no or equal to symbol. And I also have to do my shading on the same graph as well. Well, y is greater than, which means I'm going to shade above the line. So that's all the solutions to this particular inequality. I'll do the next one in red. So now in red, on the second equation, I'm going to do y is less than or equal to -x plus 1. Oh, here's plus 1. -x down 1 over 1. There we go. All right, this is going to be a solid line because it has the or equal to symbol. And I'm going to also shade here. So it's nice to shade lightly with your pencil because we're shading twice. So it is good to shade lightly with your pencil. I'm just showing this highlighter because you can see the overlap, or you can see what the solution is going to be. Y is less than, which means it's going to be below the line, which is all of these. Now the solution to the system is where the two shaded regions overlap. And that would be this section right here. So what we do is when we figure that out, that's why we shade nice and light, because then we can darken it in the actual solution. So this whole section of the graph, all of these combinations of x and y are actually solutions to both of this, both equations. Like if I look at the point 0, 0. 0 is greater than 0 minus 2. Is 0 greater than -2? It is. 0 is less than 0 plus 1. Is 0 less than or equal to 1? It is. This is a solution to this inequality and this inequality, which means this whole section is a solution to both of them. So we shade it nice and lightly with our pencil on both of them, and that overlap, that's the darker section, that overlap, those are all the points that are a solution to the system. Now, we're going to have systems. We're going to have to write systems based on what the graph shows us. So you're going to have to write a system of inequalities by looking at a graph. So for this one, if I look here, I'm just going to write the system. So I'm going to look to see, and I'm going to write them together. So the first line, I know it's got to be an or equal to because it's a solid line. I'm looking at this blue one here. I know y is greater than because it's above the line. My y-intercept is 4, and then my slope is -1. So that's just -x plus 4. For my second one, I know it cannot be or equal to, and y is going to be less than because it's below the line, and it's a dashed line. My y-intercept looks like it's crossing at 3. And it goes up 2 over 1, so that's just 2x. There's my system. And again, to check, I can take one of these points that's in the solution for both of them, and then I can see, is this a solution for both systems? That's a great way to make sure that I didn't mess up. So if I take this point 6, 0, I want to see a 6, 0, a solution to both of these. So when y is 0, and I got 6, is this going to work? Well, is 0 greater than -2? It is. So it works for my first one. And then I'm going to plug it in here for 2, 6. And I just chose this point because I like working with 0. So that's why I chose this point because it was easy. I could tell it's on both solution set. I have x is 0 or y is 0. So 1 0 is easy to work with. And so I get 0 is less than 15. Is that true? It is. So it works for both of my systems. Here was the two systems that I plugged it in for. So because that point worked for both of them, I did it right. So what you want to do is now you might see problems like this where you're looking at, well, what is a system of inequalities if 1, 2, and 2, 4 are the coordinates that belong in its solution set? Well, let's see where 1, 2 is. 1, 2 is right here. 2, 4 is right here. So I'm looking for a system of inequalities where the solution is this area right here. This is my region. Oh, let's do the exact same thing we just did. So go ahead and pause it, try it, see how you do. Go. So here's the solution I got. So hopefully you paused it, you tried it. This is my system. I got y is greater than the blue line because it's shaded above. And I got greater than or equal to the red line because it's also shaded above, but also is solid. So that's why I have the or equal to. Here's my slope and my y-intercept. I could check the 0.00 and see if it works. But actually, that wouldn't be a good point to check, right? Because that's not a solution. I would check one of the 2 points I have here. Maybe check the 0.12, plug it in to make sure that it works for both equations, and it does. I realize that this is the exact same problem that we started off with, so we are going to skip it. Now, if your problem on your note taker is different, then that's an independent practice problem, so get it done. Finally, you're going to have word problems. Okay. So first we have to write the equation from the word problem, then we have to graph it, and then we use that graph to answer a question. So Malia has $500 to purchase water bottles, $2 each. So $2 for water bottles, we'll use X for water bottles, and $3 for pairs of socks. We'll use Y for socks. So here's socks, and then here's water. Okay. Now, what I want to know is, and we know that she has $500, so she cannot spend more than $500. So that means for my inequality, this left side, the amount of money she spends on water bottles and socks cannot exceed $500. It can be exactly $500, but it cannot exceed it. So she has to spend no more than $500. Well, she also needs to buy a total of at least 200 items. So she has to buy at least 200 items. That means the amount of socks and water bottle items that she buys, has to be at least greater than or equal to 200 items. Here's my system. So what I'm going to do is I need to graph this system onto this coordinate plane. I would graph it by finding the intercepts. Okay, I would graph it by finding the intercepts. And when I graph it by finding the intercepts, I'm going to create my plane because I know my x and y intercept are both going to be 200 for this one. So I think I'm going to count by 20s. So it's going to be 20, so there's 60, 80, 100, 20, 140, 160, 180, and then that means this top one is 200. Okay, and then I'm just going to count by 20s down here as well. So here's 40, 80, 120, 160, 200. So when I graph these by the intercepts, I'll graph this first one in purple. Okay, I'm just doing a dot here to show this in my purple graph. Both intercepts are 200. So I can buy 200 of one, 200 of the other. And so I know that, I'm going to try to draw a line. Okay, it's not the worst line in the world, not the best. So there's my line, 200. And then we know we have to buy at least 200 items. We could buy more. So that's why the shaded region is above that line. Okay, so the shaded region's above that line. So let's go above here. Okay. Now for the next one, I'm going to graph by my intercepts again. So my x-intercept is going to be 250 because 500 divided by 2 is 250. Well, I didn't make my graph long enough. Shame on you, Gradius. So let's just kind of extend it here. That's okay. Worse things have happened. There's 20, 40, 60. There's 240. There's 260. So it's right in between here. There's my x-intercept. It's not perfect, but it'll work for what we're doing. Y-intercept is 166. Okay, because 500 divided by 3 is 166. So that's going to be somewhere like right about there. So I can connect those lines. Now she can't spend, this is how much money she's spending. She can't spend more than this amount. So that's going to be shaded below. Ah, wrong one. So now hopefully I can see that overlap right here in the middle here in between. This one a little bit smaller. For this, I'm going to fill it in a little bit darker. Here's my solution to my inequality. All of these points are possible solutions. Then I can check to see, okay, can she buy 75 water bottles and 100 pairs of socks? Well, 75 water bottles, 100 pairs of socks is right about here. That is not part of the solution. That will not work. And we could have known that because 100 plus 75 is not at least 200 items. Okay, that's it, guys. So it's just graphing the two inequalities on one coordinate plane and then seeing where they overlap. I hope this video helped. If you guys have any questions, let me know. Greedy us out.